on cutting-edge technologies in robotics and automation, hosted by Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tiruchengodu, Tamil Nadu, India, and powered by Institutions Innovation Council, Ministry of Human Resource Development Initiative, Government of India. Day 2 session of webinar, Future of Robotics and Automation, delivered by Mr. T. Ruban Sundarraj, Singapore. I now request our Senior Professor Dr. N. Saravanan, Department of Mechatronics Engineering, to introduce our today's chief guest. Sir, please.
Thank you, ma'am. It's my pleasure. Ma'am, it's audible?
Yes, sir.
It's audible. It is audible.
It's my pleasure to introduce today's chief guest, T. Ruban Sundarraj, software developer, WS Audiology, Singapore. So he did his post-graduation in Master of Science in Smart Product Design in the year of 2013 to 15 at Nanyang Technological University, Singapore, and he did his undergraduation in Mechatronics Engineering in the year of 2009 to 13 at K.S.Rangasamy College of Technology, Tiruchengodu. So at present, T. Ruban Sundarraj worked as a R&D engineer, concept development department, WS Audiology, Singapore. So before that, he worked as a R&D engineer, PTS Technologies Private Limited, Singapore. Mr. T. Ruban Sundarraj has around 5 years of experience in product development, software development, and in Internet of Things related solution development. And also, he holds 2 patents and he holds 2 international journal publications and 1 design publications also. He had developed many projects in the areas of IoT-based temperature sensing for sheep and cattle management and IoT-based poultry farm maintenance, online stack analyzer, hourly forex price prediction using artificial intelligence for gaming and game development, and also developed the project overmolding hearing instruments. He is a versatile problem solver with experience in web application development, computer Android application development using Java and artificial intelligence and big data analysis. He is a firmware development using C in microprocessor Python. So such a person is with us. So once again, I am very much happy to introduce such an eminent person, Mr. T. Ruban Sundarraj. He is also our alumni. So now he is in a software developer, WS Audiology. So I welcome you, Mr. T. Ruban Sundarraj. So thank you so much for giving me the opportunity to introduce such a wonderful person. So thank you once again.
Thank you, Professor. We are very happy to have our alumni, Mr. T. Ruban Sundarraj here. Sir, the forum is yours. Please proceed.
Yes, ma'am. Thank you, ma'am. Thank you, sir. Thank you for the warm welcome, and it's my a pleasure to be here sharing with my juniors my experience in robotics and automation. So straightforward, I'll start sharing my screen so that we can go to the slides.
Yes, Mr. Ruban. Yes.
Can you all see Can you all see my screen? Hello, can you all see my screen?
Yeah, yes, sir. It's very clear.
Okay, I'll just start. So thank you, Saravanan sir, for the warm introduction. So this is about me. So basically, he said everything. So I studied my bachelor's mechatronics engineering in KSR College. I studied mechatronics, and then I studied the master's in smart product design in Nanyang Technological University. After that, I started working in Singapore. So I was working in PTS Technologies for like 2 years as R&D engineer. And then I moved to WS Audiology as a concept development engineer. Now I'm working in the same company as a software developer. So apart from that, I have a few of my personal works where we can learn a few things. So I have this platform called letscode.xyz where you can learn programming. Then I have and I mentioned shares.com where you can know about stock analysis. And then I have another platform called ndgames.xyz. It's a competitive gaming platform, so it's work in progress. So all these things I did in my free time when I was working full time in some other company. So yeah. So apart from, so I have experience in product development. So product development in the sense IoT sensors, hearing instruments. Hearing instruments are basically hearing aid that goes behind your ear. So it helps the people with the disability to hear. So it basically amplifies the sound that's coming onto us. So apart from that, we also in line with those projects. So I also did software development for the sensors, IoT sensors. So we discuss more about this later. And then IoT related solutions. So I have two patents. Two patents are in the field of a hearing instrument as well. So yeah, one is for method of manufacturing hearing instrument. So it's a overmolding hearing instrument. And then another one is for magnetic resonance charging. So it's one of wireless charging techniques for hearing aids. So apart from this, I have two international journals. So I published this journal under our Ilangavan sir. So he was our guide for our final year project.
Ruben sir, kindly unmute yourself and then proceed, sir. Disturbance coming so one way. Ruben, kindly unmute yourself and then proceed.
Okay.
Okay.
Okay, thanks. I didn't mute my microphone, so I don't know why it's going like this. Okay, so okay. So the international journals published were through our Ilangumaran sir in KSR. So he's our department head now. Yeah. So moving on. So this is the content. So we will discuss about innovation, some of the greatest innovation of last decade, basically in last 10 years, and then trends in automation in 2009. So that's when I started. So I started Mechatronics in 2009. So I passed out in 2013. So we discussed just an overview of what I know about mechatronics and automation when I started. So and then a current trend and future trends in robotics and automation. So what is happening at the industry now? Then what's future looks like, and then forefront in auto industry. So basically, when I was studying, so most of the mechanical engineers and mechatronics engineers are excited about joining an automobile industry. So we also discuss about what's the forefront current technology in automobile industry. So we get an overview of that one, and then we go more into like overview of ROS operating system and why it's important. If we are doing a mechatronics or robotics, and then we'll go over Internet of Things. So I will share my personal experience in Internet of Things, and then we'll discuss about some of the skill set like Python programming and why it's good to learn, and then Arduino programming and Arduino hardware, then neural networks. So why? So what's happening in the field of neural networks as well? So I'm also involved in some of the projects that uses machine learning and neural networks. So and finally, we will discuss about a final year project. If there is any takers for that one, so we can discuss further as well. Yeah. So I will go into the presentation. So this is the first one. So basically, we discuss. Okay, so innovation. So when we ask what is innovation, so anything and everything that helps in human evolution is innovation. So if we go like 200 years back, so we were fighting war, and then I mean, someone is called a superhero. If you are a great warrior in the war. So, but nowadays, if you see what's happening, so if you look into like what's happening in the field of technology, which is taking us to the next level and next level. So now we are talking about going to Mars. So 200 years back, we couldn't even think that we could be doing what we are doing now. So whatever things that have happened for the past 200 years and since the beginning of life, so everything has contributed for this human evolution. So you can call innovation as anything and everything that helps in human evolution. So let's say that let's say we are doing a task, and then it takes step A, B, C, and D to do a certain job for business or humans. So let's say it takes like basically 4 steps, but you have a black box. So with that black box, you are reducing the number of steps that it takes from A, B, C, and D, 4 steps. Basically, you are reduce it to like 2 steps or 3 steps. So that's innovation. So innovation can be as simple as that. And then another thing is, let's say that if it cost us like 10 lakh rupees to operate a business, and then we have a black box, and suddenly that black box reduces the cost by certain percentage, like 50% or 20% or whatever. So that black box can be considered as innovation. So no matter which mini project or final year project, you are doing as a students, so you can try to map. Okay, so what are we actually trying to do with this one apart from meeting the requirements of the final year project? So is this innovative enough? So how can you say if it is innovative enough or not? So you basically you can write it down. Okay, so without this solution or without this project, so this is how the current state looks like. Then with this solution, the current state or the future state will be easier. So if you can give valid reason for that one, then you can call that you have innovated something. So that's basically innovation. So how to innovate? So how to innovate? So basically, since the beginning of life, so we do this, right? So we live in a place, we eat, we educate ourselves, we entertain, we communicate, we travel, we sleep, and we get sick, and then we go to doctor if we get sick. So if you look into what are all the things that takes up the basic things that we do every day. So live in a place, the real estate housing. So estate housing, we had the land brokers, if you want to buy a house and stuff. So the old story is like we have a broker, we go talk to him, and then arrange for a meeting, and then finally, if he likes the place, then we pay him, and we also pay him a commission. So now you have an housing.com. You just go there and check out the house, and if you like it, then you make a transaction. So the thing is still the same. So we still live in a place where we need a house, but the way we buy the house or move from one house to another house is changing nowadays. So that's innovation. So eat. So we were eating since we are born. So but what has changed now? So if you see what's happening in the industry, Swiggy, Zomato, and all these players are helping us deliver food to your doorstep. So that is innovation. So, but still we have to do agriculture, we still have to cook food and all those stuff. But now we are feeling it's more comfortable to order food rather than cook ourselves because of, all these uncertainties, pandemic, basically COVID-19 or coronavirus that's happening. So we are still eating, but there is this innovation that helps us, it's actually changing the way we bring the food to us. That's the innovation. So education. So since the beginning, we are going to schools, universities, so on and so forth. But if we see now what's happening, the Baiju is one of the online platform to learn new things. So it's one of the most valuable startups in India. So it's actually changing the trend in online or basically in education. So and we have a lot of other platforms like Coursera or Udemy or many other platforms that helps us to learn new things at a fraction of cost. So education, we still learn, but the way we learn ourselves or way we teach ourselves is evolving. So and then entertainment. So entertainment, basically, when I was students like you all, so the movie we have to go to cinema or watch it on TV. But now we have Netflix. YouTube was still around, but YouTube is also getting more popular and popular. And Netflix is also like getting more popular and popular. And then the games and music, the way we listen to music. So when I was like a student or something, so the CD player is what that we need to like listen to music. So now it's all on your phone, or you can stream it online from Spotify or Google Play. Yeah, so we still listen to music, but the way we listen, so the way the content is delivered is changing. So that's innovation. So the communicate. So when I was in school, so the way we communicate to our relatives are through either the landline telephone or we write letters. So, but now it's completely changed. In 20 years time, it's not even 20 years. It's like 15 years time. It's a complete game changer. So we have smartphones, social media, yeah, and then the geo. Without them, we cannot have this bandwidth to like have a communication. And then SpaceX is one of the companies in US that's launching satellites to space to beam internet directly to our phones and smart devices. So the way we communicate is still the same, but the medium that we use to communicate has evolved, and then it will keep evolving as well. The travel. So I'm not sure how it was like. But for me, when I was a student, so the travel agencies, we go to travel agencies and it everything. So it gives you a travel package, and then you go through them. So, but nowadays it's a complete game changer as well. So you can book air tickets for cheaper price, and then you can choose the place that you want to stay. You can either take Airbnb or go to any one of these hotels to choose the hotel that you want to stay. You can check the prices as well. Just before you go, then you check the prices, everything here, and then you book. You make the order, then you go there, and then you stay in the hotel. But when I was student, so these things never existed. We have to go to hotel by hotel and check the price. Then you can make a decision. But we still travel. So, but the way we make our decisions are changing with these innovation. So sleep. So furniture, beds, air conditioning. So I think, yeah. So some innovation happening over there. Then if we get sick, so we need the hospitals, drugs, and medical devices. Medical devices. One of that is what we do in WS audiology, the hearing aids. So every year we launch new devices, and then there is a lot of innovation that's involved in those medical devices, and it applies for across the industry, in different sectors, not just for hearing impairment. So we are actually doing just these things that's on the left hand side, but the way we are doing these things are evolving at a rapid pace. So yeah, and we are still evolving. So that's what we can call as innovation. And if you are working on a project or anything, or in future, if you want to do a startup or something or start a business, then you can see which portion of this you are taking in and which portion of this you are trying to change, and then you can be like a certain percentage sure whether that idea is going to work out or not. If it's going to have some considerable impact on any of these things, then that idea is going to work out definitely. So yeah, this is one way that you could evaluate your ideas as well. Yeah. So this is same as what I discussed in the last slide. So for real estate, we have housing.com. For for the food, eating stuff, we have Swiggy, Zomato, and others. Then for the schools and universities, we have Baiju, Udemy, Coursera. For entertainment, we have YouTube, Netflix, Spotify, PUBG, Fortnite. And then for communication, we have smartphones, computers, social media. So other players also like Geo, Apple, other laptop developers, computer developers, Google, SpaceX for helping us to communicate. And then for travel, we have Uber, Airbnb bookings. In India, we have Ola, right? Ola cabs. It's almost same. So for travel, so nowadays people don't want to. Our finance minister was blaming Indian youths because they all prefer to travel in Ola or other rented cars rather than buying actual cars. So that our car total sales in India was going down in the last quarter. So all these things are actually having some big impact on the economy as well. So how we move things around, but make a taxi like Uber or Ola. So they want to have their own cars. So those things also helping us to change the way we behave, human behavior. So yeah, that's happening over there. And then hospital. So when we get sick, so we need any of these things. And then in that you have in developed countries, you have this smart doctor app that actually like you can consult a doctor over your phone if you have any issues. So those things are evolving as well. And then Apple, we know Apple as a tech company, but they want to make a big impact on a healthcare system as well. So in the last Apple update that happened the AirPods, you can use that as a sound amplifier as well. Basically, that helps people with hearing impairment. So those are all the things they are constantly working to like innovate and improve. Yeah, as a humankind. Yeah. So, but if you take all these things, and then when we put this on a whiteboard or whatnot, and then if you see what is the most common thing that's shared by all these players or different innovations. So programming is one of the important things that's used in almost everything that we see here. That's on top. So without programming, none of this is possible. And then computing power. So when we stream data from space, in low Earth orbit, the time it takes for us to reach our phone, it should be very, very low. If the computing happens at very slow pace, then this is a solution that nobody will prefer. But what enables this solution is computing power. Then the computing power goes almost everywhere. Swiggy, Zomato, or in housing.com, the suggestions made by housing.com, or the suggestions made on Udemy or Coursera, or music suggestions made on Spotify or YouTube or Netflix. It's all through machine learning and neural networks. So all these machine learning and neural networks are possible only through very strong computing power. So computing power, basically I'm talking about supercomputers. So the laptop that I was using, when I was studying, it's like 1 gigahertz or something. So now I can buy a laptop at 4 gigahertz. So it's increased by 4 times in like 5 to 6 years. So that's the speed of innovation that's helping us to like do wonderful things on a computer, just like that. So I can build a machine learning model on my computer that I have. So that wouldn't be possible with the computer that I had when I was studying. So all those things are contributing for evolution, basically. Yeah. So that's, if you look into what contributes for these innovations that we discussed so far, it's purely like programming and computing power. So okay, so what we discussed, these items that's on top are here. So it's all there, but that's actually tip of the iceberg. So what powers these platforms? So if you look underneath what's happening, so what's supporting all these things? You have Amazon Web Service. So Amazon is one of the most valuable company in the world now. And then you have Microsoft Azure. So they have their own computing platform. So that powers most of the systems that's been developed. And then we have hardware providers. So these web servers need some hardware to run as well. You need to have basically a supercomputer to support all these things. So we have hardware providers, and in order to make sure that the transaction between one of these servers and the end customer is secure, we need cybersecurity as well. Cybersecurity is one of the things that's evolving at a very fast pace. So yeah, so all these things are contributing for our innovation. We are moving very fast. So this is, I will run very fast through this one. So this is like the steps A, B, C, and D that I mentioned early on. So let's break down the innovation in eating. So option A, we can buy groceries, cook, eat, and wash the utensils, And then option B, you can go to hotel, order food in the hotel, eat, and go back home. But you still involve this washing and stuff that's happening behind. And then the option C, you travel to hotel, order food, take back home, and eat. So yeah, these are all the ways that we can eat. But now, what's happening? This is the forefront. The forefront is what? Forefront is you order food and eat. You can basically eat it off the package or whatever. Yeah. So yeah, this is the innovation. So if you can list down what's the existing, the history of what's happening, and what's the existing trend, and what you actually want to do, and then if it reduces the number of steps, and then you have a good opportunity there. So that's how you can evaluate your ideas for anything. So we just compare. So early on, so these are all the things that we need. Utensils, gas, groceries, if you go to hotels, you need the hotel basically, and then a stove. If you are moving around, so you need a vehicle to move things around. So if you have these things, 10 years back, you can basically, even 5 years back, you can basically eat. So nobody would have forecasted what's happening currently. What's happening currently is, so let's say we order a food, so it goes to GPS, telling the person on the other side where we are located, and then based on the GPS, he's bringing the food to us from this place. So now what it involves, you need a computer or smartphone. You need all these programming languages to make it happen. You need the servers, then you need the smartphone or computer, either one of those. So it's actually like, nobody could have thought we need a satellite to help us to eat a food of our choice. Nobody could have thought 5 years back, but it's happening. So what's going to happen next 5 years? It's too hard to predict unless until we work on one of these technologies. So that's important. As an engineer. So if you see like the forefront in cars, so probably most of you guys would have seen this one. So this is a self-driving car. So you choose your destination where you want to go. It's from Tesla, and then it just takes you all the way to the destination. So it navigates the route. It stops for the traffic lights. Then it makes a decision how to make the turns and all those. Then it's going to reach the destination. You can just watch this video. There is no audio associated with this one. So it has to change the lane. It has to slow down if the person in front of the driver in front of is braking. And then it has to stop for the traffic light, and it has to make the right turns. This is one of the impressive thing that's happening currently in the automation world. So, and then this is a fully electric car. So when I was studying, so the thermodynamics, so we have different parts in thermodynamics, so 1, 2, and 3. So, but now it's all electric. So electric is taking over with battery technology, lithium-ion battery and stuff. So it's just happening at very fast pace, and then we have to keep ourselves updated to stay competitive. In this field. So here, what are all the things that have happened? So if you see how, basically I can give an overview of how this tech works. So you have, basically we can call it a supercomputer, but it's not in large scale, but a smart computer that's running a neural network that takes input from a few cameras that are around this car. And then you have a few sensors, basically like ultrasonic sensor that tells how far another vehicle is and stuff. And then it gets, and then they build a machine learning model, a neural network model. So that model gets all those information about the ambience around. It takes all those information, and then it makes a decision.
Ma'am, I think you can do from your side, ma'am. Ruben sir has to come out and we have to click on unmute.
Hello, can you hear me?
Yeah.
Yes, sir. Yes, sir.
Yeah.
You're right.
Yes. So yeah, so all these things are possible only because of the technology. But you can ask, what's the commercial aspect of this one? So if you take business like Uber or even Ola or other taxi service providers, so those people are running at loss. Basically, they are losing money to run the business. So their money are basically their operations are basically powered by investors' money. They're hoping that in future they will make profit and then they can make good money out of it. But when we see like who takes the big chunk of the money here in Uber or even Ola, so the driver and the vehicle takes big chunk of the money. So if you are renting a car, you rent a car from someone, then you hire a driver, and then you run that as a taxi. Let's say you have 100 fleets of taxi. The big chunk of your revenue will go to the driver as well as the car owner. But let's say that you have a self-driving car solution. So you can eliminate the cost of driver, saving a lot of money from the current business model. So that's the big advantage of this self-driving car commercially. Personally, if you are making travel possible for like almost anyone and everyone who doesn't know how to drive. So that's the benefit of this one. Then we go to the next slide and then we just see what's happening. So this is all people are right. This is how YouTube makes money, right? So this is the most powerful operational rocket. Uh, Operational rocket is the current one. So if you look into the history of rocket industry, basically you launch a rocket. The rocket, the big chunk of the rocket is fuel. You need fuel to power this rocket out of the Earth's atmosphere, and then basically we discard the rocket. It falls into wherever ocean basically most of the time. So now what's happening here is the rocket that's been launched. Now after delivering the payload, it lands, and then we can reuse it again. So if you see, if you want to compare this to to something that we are aware of, just imagine you take a pencil and go to a building that has 10 floors, and go to top of the building and then drop that pencil, and you have to make sure that that pencil lands on the ground like how this rocket lands. So if you that's like almost impossible, and then nobody has tried it. Even NASA and other space industries, they never attempted to reuse the rockets. But this company, a startup in US, they've made it possible. So and they are working on a lot of other things that makes aerospace industry interesting as well. So but if you look into what's the common thing between this solution and this solution, you have an operating system, basically ROS or something similar to ROS, that's making all these decisions to when to open this landing legs and when to initiate this landing burns, and then how to navigate to this fixed location are made by a computer that's inside this rocket or inside this rocket for this case, and then it makes the decision of landing. So and then it's working perfectly fine. That's a success. Yeah, so we have an operating system that runs something similar to robotic operating system, and then it gets all these ambient information, the surrounding information, and then it makes the decision like whether to slow down or apply brakes or turn and all those stuff. So yeah, that's impressive. So moving on, so we go into like automation now. So moving on, when I was in college studying mechatronics, so this was like sort of state of the art. So we have all these sensors, and we could interface the sensor to either microprocessor or PLC, and then we make a decision. It's either to turn on a motor or turn off a motor, or we can do a lot of other stuff. So sense, process, and actuate. So this is what happening basically. A few years back in the field of technology, hardware related technology. So, but if you fast forward, if you look into what's happening now, so we have these sensors, and then we have these processors that are like a supercomputer of my time when I was studying in college, and then you have all these scripting language, basically ROS or OpenCV. OpenCV is to get your visual input, process image processing basically. It's a library from Python. And then a Python programming language, it's a programming language. Then you have an operating system. The most common operating system that's used in the field of automation and stuff is like Linux. So Ubuntu runs Linux basically. And then all these things, you can run this entire package on a small hardware like this one. So this is actually a microprocessor, it's Arduino, and then this is Raspberry Pi. So we have to write a program that's similar to human intelligence to make these things happen. So basically this human intelligence. So we are driving for past 100 years. So, but if you want to automate the driving process, you need something that's better than human intelligence. Yeah. So we are creating this human intelligence through these technology, basically everything on the left-hand side from here. And then we make the decisions. So sense, process, make decisions. So it's no more actuation now. So we sense, process, and make decisions. So the decisions are getting bigger and bigger now. Yeah. So moving on. So if we look into forefront in auto industry, so the auto industry is like what we saw in Tesla, right? The Tesla video. So we have a supercomputer. The supercomputer can be like anything, but it's powerful enough to meet our needs. If you want to do a self-driving car, then of course it has to be way more powerful. And Tesla is developing their own computer hardware to make those decisions. So if you look into who is the industry leader in terms of building hardware for these machine learning and artificial intelligences, NVIDIA. So NVIDIA, if anyone is into games, so they produce graphics card. So an graphics card is important to make or process all those input like vision inputs and all those stuff, and then make the decision to like how to drive the car. So, but what Tesla did was they were using their hardware for some period of time, and then they decided to build their own hardware that's way more faster than NVIDIA's hardware. So the hardware that we want to use, because their requirement is they want something that's fast enough or faster than NVIDIA. So they build their own hardware for that one. So the hardware that we are choosing, let's say if Hyundai wants to build another smart car, not self-driving car, but a smart car. So they may want to invest in a better hardware. So the hardware requirement depends on their requirements. So how smart you want the car to be. If you want it to be really smart and self-driving, then we should go for something like what Tesla did. And then we need a processor. So the processor is something that you can use everywhere in a car. So let's say you tap on the door and then you want the door handle to open up, then you can use a processor there. You can use a small relay or switch also fine, yeah. But you take the input through one of the sensors like a touch sensor or proximity sensor based on your requirements, and then you can actuate it, just open it up. So you have a processor, and this one is Wi-Fi based one. So ESP8266, if I'm not wrong. So it runs on, you can Wi-Fi module. So let's say if you want to trigger something, you can build IoT solutions basically with this one. Then this one is a normal microprocessor. Basically it's a microcontroller. So you can program this using, it's one of the most popular. You can program this using language. Yeah, they have their own IDE to do the program. And then they have just community to to support this. Yeah. And then you need all, so no matter what, so you need almost all of this, But if you are specific into certain task, if you go work for an auto industry that is working on these technologies, they will either ask you to like take care of computer vision or building neural networks or operating system. So, but all these things goes inside the technology. Then we have all these different sensors that goes inside. Then in cars, the cars are getting smarter and smarter now. So to measure, to sense whether anyone is inside the car, you use the motion sensor, touch sensor to open a door or cabinet in a car, and then ultrasonic sensor to detect how close another person on the road is. Yeah, you all these things goes inside. And then let's say you want to have a smart navigation system to help you with traveling. Then you need a GPS, so you get the satellite information as well. So all these things goes inside a car that's making it the future of the auto industry. It's not just thermodynamics or engine that I was focused into when I was studying in university. So technology is evolving at very fast pace. So almost most of the manufacturer auto industry, BMW, Audi, all these big players are Toyota are investing significant amount of money into battery electric vehicle that eliminates internal combustion engine completely, and then move on to three-phase induction motor powered by a lithium-ion battery. And this battery technology is evolving as we speak. Yeah. So things are like moving very fast as we're speaking. Yeah. Okay, so now we just go a bit technical and then we discuss about ROS. So ROS is actually a robotic operating system that you can build real robots with ROS. So first and foremost, if you look up, so this information is from Wikipedia. So if you look up into Wikipedia, ROS is not an operating system. It provides service designed for heterogeneous computer cluster, such as hardware abstraction, low-level device control, implementation of commonly used functionality, message passing. So these things we will discuss in the next slide. So what they're telling us, so ROS is not an operating system. So let's say that you have a different microprocessor. So we go back to this slide or even to this one. So better we go here. So you may have tons of not tons but a handful of microprocessor everywhere around and sensors everywhere around that's gathering all this information. So when we gather all this information, we need to make decisions. So to make decisions, you need a system that's specifically designed for this one, and that system is ROS, robotic operating system. So it helps us in managing the heterogeneous computer clusters and low-level device control. Yeah, and then it uses a technique to pass the message, so which we discuss later. Next slide, to make the decision of what to do. Yeah. So basically, it's written in C++, Python. I don't know what's Lisp. So and then operating system, you can use it on Linux, Mac, and Windows. These two are experimental, and it's quite common in Linux. The Linux, what we discussed is this one, Ubuntu. Ubuntu is one of the Linux-powered operating system. So we can run ROS on Linux as well. So if you know Python and how to use Linux, so basically we can build a simple robot. So that's what I'm trying to see as a starter. So, but we have an idea of like what ROS, but to get a better idea, so if we have a look at this picture, then we get a better idea. So all these sensors, the sensor that goes inside and small microprocessor, we can consider them as nodes. So this node is for ultrasonic sensor at the front of the car. This node is for ultrasonic sensor at the back side of the car, and this node is for at the sides of the car. So and then you have another node that's a microprocessor that basically makes decision. So all these nodes will publish their information as a message to a topic. So that topic for this node is, what's the ultrasonic number for the back side of the car, and this is, let's say, front side of the car. So what is the numerical value in centimeter or millimeter or whatever the accuracy that we prefer. So all these things, you will have a different topic, right? So the topic for this one could be like, okay, at the front side of the car, what is the distance from the next immediate vehicle? Let's say it's 0.5 meters. On this side, the topic is like front side, the value is the topic here. And then it's like 0.5 meters, 0.5 meters, 0.5 meters. So all these goes under like different topic, front side, back side, and right and left side. So and then there will be subscribers for this topic. And these subscribers will be monitoring these topics all the time. And then let's say that you want to apply brakes when the value goes to 0.4 meter or 0.3 meter, then this will always be checking what is the value, 0.5, 0.6, 0.7, 0.4. Okay, then it's time to apply brake. So it will apply brake. So and then another node that's making another decision. So all these sensors basically act as a publisher to a common box called like topic basically. And then let's say you want to have a few other decision makers here, then you can subscribe to the respective nodes and then you can make the decision. So that's basically ROS operating system. So if you look up in Google, so there is a ROS wiki which you can go through and learn how to build a robot in a few weeks. Basically, you can manage to build one. So that's to keep it simple. So that's actually a ROS here. So and then another topic that we discuss is Internet of Things. So before we discuss what's in the slide, so I can share my personal experience here. So after I graduated from Nanyang Technological University, I started to work for PTS Technology, as what Saravanan sir mentioned. So what I was doing in that company was, so they are basically IoT solution providers. They have an R&D team that's working on that one, and then I was working in that R&D team. So what we do, so if we take, almost most of the people who are in India, like aware of agriculture, in Singapore, we have no agriculture. If we talk about agriculture, they have very little knowledge on how to do stuff. But as we are from like India, so we know everyone is involved in agriculture. So some may have like aware of chicken farms where we grow chicken, and then we kill them and eat. Cattle farm in Western countries, they kill the cattle and then they eat it as food. In India, we collect milk and then we just drink the milk. So let's first talk about cattle farm. So in Western countries, let's say you take a cattle farm, there can be like 10,000 cattle or 20,000 cattle in a farm. So it could be like big land, and then they may be like growing cattle. So they will grow this cattle like this. So probably 5 cattle in one particular area. Area can be like 15 feet cross 15 feet. So you may have like 5 cattle inside the one. Then another 15 feet cross 15 feet, you may have another 5 cattle. So you will have thousands of marked area like that where they grow cattle. So if you look at the economics of this one, the cost of one cattle over there costs like 10,000 to 15,000 pounds. That goes to like close to more than 10 lakh rupees. One cattle, just one cattle. You can just check Google for this one. So if one of those cattle gets sick, get fever or some other disease, it's very fast for that disease to spread to another cattle. So let's say if one cattle in one area like 15 square feet cross 15 square feet gets sick, so it's easy for it to affect the other 5 cattle in the same area. So basically, let's say if these cattle get sick and die, so the cost to the company is 50 lakh rupees loss. 50 lakh rupees is like a lot of money. It's like half crore rupees. So what they do is, though, they decided to invest on a sensor solution to take care of this cattle. So we developed a temperature sensor. They call that a bolus, BOLUS. So we will inject that bolus inside the cattle. So it goes inside the cattle, and then the density of the bolus should be strong enough inside the cattle stomach throughout its lifetime, or at least 1 or 2 years. So you have to take care of the design as well. And apart from that, you have to transfer temperature data wirelessly from inside the stomach to another base station that's receiving the data that's outside somewhere. So when we get this data, so you can have a notification, or it's up to us to design the app. So what we designed was to give notification when the temperature goes above 37 or 38 degrees Celsius. I think somewhere close to 40 degrees Celsius. If it goes to 40 degrees Celsius, we are sure that this cattle have some health issues, basically fever. So and then we immediately trigger quarantine procedure to separate this particular cattle, so that it doesn't affect other cattle, as well as you save money. So that's one solution that we did. So let's say 15,000 cattle, then we have to do 15,000 sensors, and then we have hundreds of farms like this in Western countries. Yeah, so it's a big business that's evolving because of this Internet of Things concept. And then another thing that we did was the same sensing concept, but for a chicken farm. So the chicken farm, same case applies here. They are grown very closely. You will have tens of thousands of chicken in one shed, and then it's important to monitor the health of these chickens, so that you save a lot of money when it gets, by avoiding it to get sick. So we also did it as well. So all these solutions, so innovation, right? So we go back to the same definition of innovation. So this innovation, it may sound like a bit funny because we are putting temperature sensor inside an animal, but it helps us to save lots of rupees, basically crores of rupees. So that's innovation is made possible because of Internet of Things. So that's my personal experience. But when we go into the definition, so what we discuss in the slide now. So anything that's connected to internet that can be visualized or controlled over a smartphone or computer application. So that's basically, you can call that as the Internet of Things. So even a smartphone, if it's connected to internet, then it goes on Internet of Things. So the benefits, it reduces cost, it reduces cost, increase efficiency. So when we go back to that cattle story, so how do they check the temperature of the cattle? The temperature of the cattle one by one using the infrared thermometer, or some temperature sensing solution like that. Just imagine how long it will take to measure the temperature of 15,000 cattle if you are doing it manually using an infrared thermometer. That's going to take lots and lots of human hours. That's going to contribute to cost. The solution that we just discussed, we could either reduce cost as well as increase efficiency and improve your decision making. So you are making an early decision by quarantining a cow that got fever a few minutes back, if you are monitoring it continuously. So you are improving your decision making, better monitoring and surveillance. So yeah, monitoring is also like we discussed. And then improved customer service. The customer service concept applies to some other business elsewhere, but not for cattle. Yeah, but you can see that you have like tons of benefits with this Internet of Things solution. So if we look this into an perspective, okay, what's happening here? So if any one of you guys are like following these Google conference, they will have a developer conference once a year, and then Apple will also have their own developer conference once a year. Also, obviously, Microsoft will have their own conference. We'll be reporting. So we have, I don't know the exact number. Say like we have 1 billion or 2 billion active Android devices or active computers using Microsoft operating system, or active phones using iOS operating system.
Oh, thank you.
So see, like what they're talking, 1 billion is equal to if we use our convention of for the numbers they are predicting is, so we are already into 2020, then we are expected to have probably by end of this year IoT devices. So it could be a small sensor that's connected to an internet sensor. So it's one of business information provider, news tellers. They said that there will be 64 billion IoT devices by 2025. So that's like 3 times growth. So in next 5 years time, and then all sorts of data. It's hard to see this number into perspective, gigabytes, terabytes, and so on and so forth. I don't know what comes after that as well, but it's going to generate lots of data by 2025. And then we should have the intelligence in terms of writing data analytics or whatever, as well as computing power. The major solution providers are like Microsoft, Microsoft Azure, Amazon Web Services, Google Cloud, so on and so forth. They're providing the processing power, computing power. So all these data will be processed by either of those processing or computing solution providers, and then they will be making decisions to make our life better, which helps us to evolve further. Yeah. So this is what happening in the world of Internet of Things. So looking forward just 5 years into future. So this is based on what we know currently. So probably it could be way better than what's expected. Yeah. So this is Internet of Things. So this is actually ESP8266. So you can buy this in Amazon in India. So it's going to cost, it's going to cost few hundred rupees. And then let's say if you want to build an IoT network inside your house. So each of these can have a few. You have a few GPIO interface to these MCUs, So you could interface few sensors and actuators, and then you can control them wirelessly over Wi-Fi. So all these can be powered over Wi-Fi. So all these will be connected to an Wi-Fi network. Then that Wi-Fi network will be connected to a server, transferring which knows the state of these individual GPIO pins. So it knows the state. So and then let's say this pin is connected to a relay that's connected to your light or fan. So the state, if it is 1, it will be 1 in the server. Then if you want to change the state, you have to switch it to 0. So you can either write an API to do that from your smartphone. Yeah, you can write an application to do that. So this goes under IoT. If you want to know about basic building blocks of this one, it's just basic. So you have to code this one. You need a lot of libraries. Node.js is a server-side scripting language. MongoDB is so you avoid writing headache-causing SQL queries. So all these things will go on the server. This server most of the time runs Linux, probably Ubuntu. And then that Linux, you have to do shell scripting or Python scripting and run this server. And then on the user side, you either have to have a web application. It can be either written in HTML, CSS, JavaScript, or you can write an application using C# or Java, or you can build a smartphone application to control the state. So basically, all these things are to change the state from 0 to 1. It's a very simple example, but a lot of tech goes under this one, and then a lot of cost saving is done as well. So if you look into historical data about the amount of wasted electricity in industrial space, if we go work for all these electronic city in Bangalore, we have all these IT parks, right, in India. So let's say if you keep the lights on or air conditioning on for even for like a few hours, it's going to cost them lots and lots of money over a period of time. But having a solution like this that turns off by itself when it detects no movement, and then if the time is after 6, then that's going to save the company lots of money. So all these things either helps us to make better decisions or save money. Yeah. So that's Internet of Things. So apart from this, so we discuss about Python programming. So the Python programming, let's say we discussed here, right? So it's going to generate like bucket load of data. It's like lots of data, but we need someone to process these data, make right decisions out of these data. So that's when science comes in. Under data science, you have data engineer, data scientist, data analytics. You have different job specifications. So one of the most popular skill for the data scientist is Python. So 72% of them uses Python, and the rest goes as first. So in our college, we will be using MATLAB, right? So we have a course on MATLAB or we have a special course. So I strongly suggest to take MATLAB if you have an opportunity to learn MATLAB. You can also learn Python, or it's a good programming language to know even if you're just mechatronics engineers. So it's used almost everywhere. Basically, Python is C wrapper. So they took C programming language and then they bundled it. So they packaged it into different libraries, which a simple scripting language. It's easy to understand, called Python, and then they're calling it Python. So they are actually everywhere: machine learning, scientific computing, business intelligence, data analytics, web application, neural networks, image processing, audio, video applications, stock analysis, self-driving cars. So it's just everywhere. So I strongly learn Python. So you can just learn. It's for free. You can download the software. Is free. It's very lightweight. You can run it on your simple computer, and then you have lots of tutorials online for free, and then you can go through those tutorials. And then professionally, where it's being used, it's used almost everywhere. So Google uses Python, Instagram, Uber, Tesla, YouTube, NASA, Yahoo, and many companies uses Python programming. So that's about Python programming. Then we just have a look at Arduino microprocessor, the benefit of having these boards. So when I was studying, so we were using 8051 microprocessor, and then we were programming in assembly language, hexadecimal. So let's say that's a professional way of learning. Yeah. So we know at assembly level what's happening, so that you can write a really optimum, or you can really design a really optimum code that runs without any overhead, and then consumes very less power. So it's better we go for assembly language. But let's say that we have an idea, then you want to use a microprocessor for that one, and then you want to see how effective that idea is. So that's when the boards like this comes into play. So it's just you can write a C program. You can use C program to code any microprocessor related application that you want. You can interface any sensor that you want, and then you can test out the idea and if it's working fine. Let's say that you want to build a drone. So it's not advisable to build a drone with build a fully working drone with Arduino, because it takes a lot of overhead and then it slows down. Then the decision making is a bit slow. But you want to test out the idea first. So you take one of these smaller boards, then you write the script and then you test it out. And then if it all works fine, then you can go back and then write it in either the actual C program or assembly language. So it helps us to do fast prototyping. That's the biggest application of these Arduinos. And then in most of the universities, even in NT, these boards to do their final year projects with these boards. So the smart glove that we spoke about earlier on, Saran sir spoke about early on, was that uses this microprocessor. Forget the number. So Atmega microprocessor is being used, and then I program that in C, and then it helps in playing games wirelessly. Yeah. So that's an overview of this one, and then you can build everything, any computer application with any sensor-based application, anything basically with you can build an RC car, smart RC car, or drone, or build an IoT network or whatnot. We can also build a smart irrigation system to efficiently use the water resource available. Yes, so that's with regards to Arduino. We touch base with machine learning and neural network. So if you look into, like, I think we have a course on machine learning and neural networks in KSR. So I just saw we have a BE in artificial intelligence, if I'm not wrong. Yeah. So what we are doing here is we are telling, okay, so all these things that we discussed in C program or even in Python. So you are writing a specific instruction that needs to be executed for a certain task to happen. But if you take machine learning, what's happening is we are trying to replicate how humans, we make decisions. So let's say you take a baby, and then you light a candle. The baby wants to touch the candle. When you tell the baby not to touch, it's not going to listen. So the baby will stop touching the fire only after it experiences the heat from the candle. So it's learning through experience. So the machine learning is basically like that. It's in a fundamental terms. So you will have lots of data that we discuss, 79 zettabytes or something. Yeah, you have lots of data, and then you want to make with those data. So how do you do that? How do we do that? So we take those data that generated, and then we train a machine learning model. Under machine learning algorithms, we have different types of algorithms. So we get to learn, we use each of these algorithms, or we pick few and then we test out few of those algorithms on which one to use. So how do we test out the accuracy? After feeding, like let's say we feed 1 lakh how to drive a car by itself. So and then after that you test out the data. I mean, you test out the training by having checkpoints. Okay, so did it stop for the traffic light? Did it slow down when the other guy slowed down? And then did it slow down when there was another guy closer to it, closer on the other side of the lane? So if all this, so you can basically do that in a virtual simulation. You don't have to drive the actual car. So and then you can score, give a score. Okay, so yes, no, yes, yes, no, no, based on the criteria that I just listed, and then you can see how good the model is. So if it didn't stop when the guy in front, then you give a negative mark.
Ruben sir, kindly unmute yourself, sir. Ruben sir.
Yeah.
Ruben, your audio.
Yeah. Now it's fine, right? Yeah.
Okay,
Sure.
okay.
So we have supervised learning. It's a very early stage classification. You have different techniques under supervised learning and under reinforcement and unsupervised. So if you take in a simple terms, you have three different types basically: supervised learning, reinforced learning, unsupervised learning. In supervised learning, you have existing data that knows what is the right answer as well. Then you inject those data into a machine learning model, and then you train it. So this machine learning model will go through each of those data, and then it will try to remember those data. So that's the technical part if you go deeper. And then based on those weights and biases, it will make predictions on unseen data, the new data that we. So that's called supervised learning. Reinforced learning is like teaching computer how to play a game. So you have an environment, then you have an agent. Agent can be a player. So and then this guy makes a decision that's called action that have some impact in the environment that will change the state. If that change in state is the right decision, then you reward the agent, the player, and then it will try to make similar decisions. You will reward it by reducing the score or try not to make those decisions inside the environment. So that's called reinforcement learning. And unsupervised learning could be something like this. You have a bunch of data. We don't know anything about the data. It could be a data from playing games or from a self-driving car or from a rocket that's been landed or it can be anything. So, but you feed that to a machine learning model, then it tries to categorize those data. So something like this, that's angles, squares and circles. So it tries to group them together. Simple because